fire-safe cigarettes. These do not start fires. They're in America. In America now, they reckon they've reduced the number of fatalities due to smoking down by 1/3 by having fire-safe cigarettes. Now, we're looking at it with the European Union, and I think it's the way forward, because if people are smoking, if you can't set fire to the house or anything, obviously it's a good thing, and it's a good way of reducing the number of deaths every year. What other ignition source have you got? You've got sparks from welding equipment, sparks from electric motors, and sparks from grinding equipment. What control measures can you have? You ensure you use it correctly, hot work permits in place, and you can shield the area or cover any flammable materials or remove them. What about oxyacetylene welding equipment? Yeah, in the workplace. What control measures can you incorporate? Well, there's a number of these. First of all, make sure you complete the user checks of the equipment before starting the operation. Use regulators of the gas cylinder heads to the appropriate standard. Using hoses that are as short as possible. Using colour-coded hoses, for example, red's acetylene and blue for oxygen. You should fit the torch unit with non-return valves. Fit flashback arresters to the outlet of the regulators. Using crimped hose connections and not the normal Jubilee clips. Minimise the amount of combustible material in the area of the welding operation, and maintaining a fire watch. You should ensure the gas cylinders were not heated by the flame or by stray arcs from adjacent equipment, and close the cylinders at the valve when not in use. That's what you should do with acetylene cylinders. What is static electricity then? Well, static electricity is the transfer of electrostatic charge between bodies of different electrostatic potentials. Did you know walking across a nylon carpet you can generate 35,000 volts? Opening a plastic bag will create 20,000 volts. Some military equipment like an F-18, it's controlled by microchips so sensitive that a static charge of 30 to 50 volts will make it effective. So can you imagine, in these areas they have really good anti-static control. Microchips are so complex now, 1/1,000,000th of an amp is sufficient. That's all it uses. So you need good control measures in these places. What control measures can you have against static? Well, you can get a static discharger. I went to a company, I turned up this company and they had an explosive atmosphere. And it was a high-risk explosive atmosphere. And I said to the manager, what static controls have you got? And he says, we've got a static discharger. And a static discharger basically consists of a metal plate on the floor which you stand on, and there's a handle that you get hold of. And obviously what happens is, as you stand on the plate, you get the handle. If you've got any static, it will discharge the static and warn you that you had static. So it warns you. I said, that's great, I like that, yeah. I said, how many ways into the risk area are there? He said, well, there's 3 ways in. How many discharges have you got? 1. Well, I'm not being funny. A guy walking down the ground, he's going to go in a different room. He's not going to think, oh, I better go discharge myself upstairs first. In other words, although it was a control measure, it's not an adequate one. There's 3 ways. There's only 1 discharger. There was no warning telling you, have you used the discharges? That was the first thing. And he said to me, well, don't worry about it, because anyway, we have got all our staff issued on the day they start work with anti-static footwear. Every single person wears anti-static boots. The special boots that will not allow you to create this charge. And I said, that's great, that is. And as I was chatting to him, somebody came out of the risk area, 2 people pushing a trolley. So I looked, I said, hey, what's happening there? He went, so I went to have a chat with him. First of all, I said to him, is that trolley, you know, proper trolley, static wheels, everything? Yes, it's got anti-static wheels, that is a purpose-built trolley for that risk area. And I was just chatting to the people pushing the trolley. And this young lady there, I said to her, when you started the company, when did you get issue with these anti-static boots? And this lady said to me, in front of the health and safety guy, no, these are my boots. I said, no, these must be the anti-static boots that you got. No, these are my safety boots. The ones that they gave me were dreadful. My feet ached. I bought my own. I said, are they anti-static boots? They went, eh? Basically, because they didn't fit, she'd gone out and bought some safety boots that were not anti-static boots, and she's walking in there. What I mean is, some of these control measures sound all right, but are you managing them properly? Make sure you're managing them properly. Let's look at the issue of ignition of solids. Now, common materials such as wood, paper and textiles will ignite if heated to only 300 to 400 degrees, and they're also capable of smouldering. By comparison, a flame involving temperatures of 600 degrees or more while welding, an oxyacetylene cutting gets up to temperatures of 2000 degrees. So as you can see, these temperatures now, something that you might think's not going to burn, will burn. It's excessive temperatures. Metals, powders, they'll burn. This video here is going to show you what happens when magnesium burns at extreme temperatures. And this is when water's been applied. Watch this. This is only half a gram of magnesium powder. Watch how intense this is. This is a metal burning. What about the ignitions of liquids, vapours and gases? Well, with liquids, vapours and gases, hot work can ignite a mixture of the flammable gases or vapour in the correct proportions within air. Yeah, within the flammable limits, which I'll cover later. By comparison with solid ignition, very low ignition energies are required, and all of the hot work processes, including grinding, are capable of ignition in these areas. So any hot work process in an atmosphere that's flammable or explosive will cause an ignition. Again, let's just summarise the methods of avoiding ignition then. Smoking materials, you've got good housekeeping, management controls, like for example defined smoking areas. Sparks from a welding gun, you've got hot work permits, management controls, and you've got permit to work. You've got sparks from machinery, good maintenance programs, good housekeeping and the correct choice of machinery. Static electricity, safe systems of work, earthing straps you can bond and have anti-static materials, footwear example. Electrical faults, competent staff, good maintenance checks and pat testing. Overheating machinery, good maintenance programs, correct siting for airflows. Radiated heat from a legitimate source, space separation, shielding and fire resistance. The emission of flammable vapours, seal the container. And the flammable vapours present in the workplace, as above, including electrical equipment to be approved in a flammable atmosphere. That's the ignition sources. That completes this section of this element.